REST is an acronym for Representational State Transfer. This is an architectural style that's generally implemented these days in HTTP using URIs and data formats such as XML and JSON. In .NET, you create a service that supports REST by adding attributes that contain HTTP verbs. You can also specify response formats such as XML and JSON in your service. This table shows some of the verbs that you can use. The most common that you'll use are the get, post, put, and delete. Get reads data. Post and put both have the capability to create an update, but the primary difference between them lies in a concept known as idempotency. Put is idempotent. That means that it can only operate on one resource. No matter how many times you do a put on that resource with the same data, it will not change it. However, with a post you can use to send data to a resource, and you will continuously add to that resource. You'll accumulate new data associated with that resource. Another way to look at the difference between post and put is that put operates on the URI resource itself. However, the URI that you operate on with a post statement is really a handler to work with multiple resources. Delete is another idempotent operation where you can do an operation on a resource to say delete, and no matter how many other times you perform that delete, it will have no other effect. Other verbs include options, trace, connect, head, but they're not as common in your service. So let's go create a REST service. In this demo, I'm going to show you how to create WCF REST service. We have iWeather service, and it's a service contract just like any other WCF service. Also, you'll notice that I have various operations, and they're decorated with the operation contract, as are typical WCF services. What's different about this are the web invoke and web get attributes. As you know, a get is a read operation. Now, get is so common that it has its own attribute, web get. For all the other attributes, you use web invoke. Now, web invoke, the default HTTP verb is post. So this first one here doesn't have a verb because it's intended to be a post. If you look at its purpose, it's add status. The concept here is that for this weather service, maybe somebody would want to add the status of their local situation to a certain forecast. In this next example, the web invoke has a method parameter, and it's a put verb. In this case, we're making the assumption that there can only be one forecast at any given time for a given date. Therefore, put would be the best decision or the best design for this particular scenario. Update means I can either create it or I can modify it, but it's only that one resource. Here's a delete operation. And here's those webgets. Another important part of these HTTP verb attributes are the URI template. In this case, for the status, I just have a slash and a nugget right there for a value that corresponds to status. Essentially, this means that the base URI will be appended with a slash and some text that's the status. That nugget, the name of it, needs to correspond to a parameter in the actual operation. Each one of the parameters needs to be a string. In your implementation, you're free to take that string and parse it to the strongly typed value that you want. Here in the put operation, we have a put on that date, and we're giving a status on that date. So notice that each of those parameters correspond to the parameters in the actual operation. Here's a delete with a date. And then on the get, we just have a slash to say, okay, we're just going to use the base address and assume that that's going to be something that returns a collection of weather forecast. Now, each one of these operations returns XML because that's a default. However, if you want to return JSON, you can specify a response format, which is of type message, web message format, which can be either JSON or XML. Here I need to differentiate this endpoint, so I went ahead and called it JSON. And now you have an interface that defines a contract for a WCF REST service. Now let's peek at the implementation. Now this implementation should not surprise you because it implements the contract. And here are the methods of that contract. But notice that it's just the method. Things like the URI and whether it returns JSON or not are not specified. So let's do something here to test this out a little bit. I'm going to right click on this and select View in Browser. And then go look at the weather service. Now, this is the base URI. Localhost because it's the local Visual Studio web server that's hosting this. And then it shows this weatherservice.svc file and then slash. If you recall, the URI template for the get forecast was just a slash. So it's the whole base address plus that slash. And notice that I have this XML document that I got back. So that's a get. Now let's look at this service file right here to see what it has in it. Generally, you have a nugget here that says service host and an attribute for the service. It's fully qualified with the name and the name of the service. But what's interesting here is that you have this factory attribute that's from the system service model activation namespace web service host factory type. What that does is allow you to skip any other type of configuration because when this hosts the file, it sets up everything you need to host that service. It's very simple and quick. And that's why when I ran this and I selected the weather service, it counted as the base address for the service. I'll talk about configuration in a little bit more depth. Notice that I have this service model file. I have some configuration information here that fits it into a section called System Service Model. We want to expose metadata, so we can do so with the simple HTTP GET, because we have HTTP GET enabled to true on this service metadata. Here we have basic HTTP binding, which is equivalent to the old ASMX type of web service. So that's a minimal configuration file, and you don't need much there because we implemented this service host file. And that's how you create a WCF REST service. REST services are popular for their simplicity, so you can expect that consuming a REST service, regardless of whether it's from WCF or any other type of technology, is going to be simple. It's just like any other REST endpoint. You can consume the XML of the REST query, or you can consume JSON. In the next demo, I'm going to show you a couple techniques you can use to consume a REST service and use the data. This demo shows how to consume an HTTP REST service. Since I'm using async, I'll go ahead and wait the call to do demo so that I can see messages before hitting read key. As you can see, do demo is async, and I'm awaiting each method. I've set up the base URL, and I'm using an HTTP client for my communication, and passing each of those parameters to each of the methods. Here I'm doing a GET, a POST, a couple PUTs, and a DELETE, and then I'll show you how to consume JSON data. In this first example, we have get forecast, and it's using the HTTP client to call get, and it's calling asynchronously. Notice how I await the method call. I get an HTTP response message, and then I perform another async operation on that response so that I can read the string. What I'm really getting back is XML. And the namespace of that XML is defined right here. That enables me to use link to XML to read each of the weather forecast elements and parse it into an anonymous type. And now I have a list of anonymous types, which I can iterate over and write to the console. So that was get forecast. In the next scenario, I do a post. Here I'm setting up the URL. Notice that I use the base URL, and then I append a slash with the status message. I'm calling a post asynchronously with that status URL, getting the message, reading the results asynchronously, and writing them out. Again, the response is in XML, so I'm using link to XML to pull that data out. The approach is the same with the put as it is for the post, except the operation is put. As you recall, put is idempotent. So that means that when I call it twice up here, the second time doesn't change the value from the first time because I'm putting the same value on the same resource. Here we have a delete operation. Notice that I pass in a date to delete. And then I call delete asynchronously, again getting the response asynchronously and printing it by pulling the value out of the XML that's returned. In this next scenario, I'm working with JSON data. Here I have getAsync off of the HTTP client, and I'm appending JSON to the URL, just as the contract specifies for this URL. I'm reading the response asynchronously, and then I'm using link to JSON. Actually, what this is JSON.net. I pulled that in as a NuGet package by going to Tools, Library Package Manager, Manage NuGet Packages, and then selecting JSON.net and clicking Install. So this is similar to the link to XML, except I know I'm working with an array. I'm building an anonymous type and printing out each element. In this case, I use these libraries. I use the HTTP client to communicate with the URL. This is unlike the standards-based services that I used, where I would right-click and say Add Service Reference. Add Service Reference creates a proxy. I didn't need the proxy in this case. I just used the .NET libraries to call the service directly. Now let's run this. And here's the output. This is the first get, and here's the second. And in between we have status updates, we have a couple puts, and then we have the delete. And there you have a way to consume a WCF REST service.